Welcome to the course. In this first lesson, we're going to zoom out and give you a clear picture of what you're actually building and how all the pieces fit together. By the end of this lesson, you'll understand the final goal, a Node.js and Express API that runs AI models locally in your own environment using transformers.js. You'll see the three core features you'll build: age support text generation chatbot powered by Qwen 2.50.5b instruct, a Jar sentiment endpoint that analyzes the sentiment of text, and a Jar classify endpoint that can recognize what's in an uploaded image. We'll walk through the key architecture, how Node.js and Express handle HTTP requests and routing, how Transformers.js loads and runs ONX models directly on your machine, and how pipelines in Transformers.js simplify tokenization, inference, and decoding so you can focus on your endpoints instead of low-level details. You'll see exactly how each AI capability maps to its own HTTP route and what each one expects and returns. You'll also get a quick comparison between using external AI APIs and running models locally, why local models can be great for privacy, cost, and offline use, and what trade-offs you need to keep in mind around memory, compute, and maintenance. This lesson is split across 11 slides, and I'll talk you through each one with audio so you can follow along at your own pace. Pause, rewind, and take notes as you go, and don't hesitate to reflect on how you might use these endpoints in your own projects. When you're ready, go ahead and start the lesson, and let's get a solid understanding of the architecture you'll be building.
In this lesson, you're going to see exactly what you're building and how all the pieces fit together. By the end, you'll have a clear mental model of a small but powerful AI-powered API built with Node.js, Express, and Transformers.js. You'll understand the three core endpoints you're exposing: support chat, sentiment analysis, and image classification, and how they plug into a local AI stack running entirely on your own machine. We'll also step back and compare this local-first approach to using external AI APIs, so you know why this architecture matters and when you choose it. Let's start with the final destination. The project you're working toward is a Node.js and Express API that runs AI models locally using Transformers.js. There's no dependency on OpenAI, Gemini, or any other external AI provider once things are set up. You download models once, run them through ONNX backends on your CPU or GPU, and expose simple HTTP endpoints. Express gives you a clean REST interface, so anything that can make HTTP calls, frontends, CLIs, other services can tap into your local AI features without worrying about how the models actually work under the hood. Zooming out, here's the high-level architecture. At the top, you have clients, maybe a web app, a command line script, or just Postman making HTTP requests. Those requests hit your Express server, which is really just a thin HTTP layer. Express handles routing, parsing JSON, dealing with file uploads, and sending back responses. Behind each route is a Transformers.js pipeline. Those pipelines load ONNX model files that live on your machine, run inference, and return structured results. So the flow is: client sends a request, Express forwards it to the right pipeline, the local model runs, and the pipeline sends predictions back as JSON that the client can consume. Now let's walk through the three core AI features this API will expose, starting with the support chatbot. The /support endpoint is your local help agent, powered by the Qwen 2.50.5b instruct model through a text generation pipeline. The idea is simple. You send in a conversation history, a sequence of user and assistant messages, and the endpoint returns a single, coherent reply from the AI. The client doesn't need to know anything about prompts, tokens, or models. It just posts an array of messages to /support and gets back a helpful response string that you can render directly in a chat UI. The second feature is /sentiment, which focuses on understanding how people feel based on text. Here, the goal isn't to generate long replies, it's to quickly classify the emotional tone of a message, like a support ticket or a product review. You send a simple JSON payload with a single text field to the /sentiment endpoint. The Transformers.js sentiment analysis pipeline runs locally and returns a label, such as positive or negative, along with a confidence score. This makes it easy to, for example, flag frustrated customers, measure feedback over time, or tag content based on mood. The third core feature shifts from text to images. This classify endpoint lets you upload an image and get back predictions about what's in that image. You send a multi-part form data request with an image file, and the image classification pipeline processes it using a local vision model. The response includes a top prediction, like tabby cat or coffee mug, and a list of all candidate labels with their scores. This gives you a general-purpose computer vision building block you can plug into all kinds of scenarios, from simple object detection demos to more advanced workflows. Underneath these three endpoints, Express and Transformers.js work together in a very clean way. Express is responsible for everything HTTP related. It defines routes like post sentiment, parses the incoming JSON or form data, and shapes the outgoing response. Transformers.js, on the other hand, manages all model-specific work through pipelines, tokenizing input text, running ONNX models, decoding outputs, and so on. Each endpoint gets its own pipeline instance: text generation for /support, sentiment analysis for /sentiment, image classification for classify. In your route handlers, you simply call these pipelines as async functions and return their results as JSON, keeping your API code small and easy to read. Putting this into a concrete checklist, your API ends up with three main endpoints, each with a clear responsibility. Post/support handles the support chatbot, taking a conversation array and returning a single reply. Post/sentiment takes a JSON body with a text field and responds with a sentiment label and score. Post/classify accepts an uploaded image file and returns the top predicted label plus the full list of predictions. All three are thin wrappers around their respective Transformers.js pipelines, sharing the same Express server but remaining logically independent. That separation makes it easy to extend or modify one endpoint without affecting the others. So why do all of this locally instead of just calling a third-party AI API? There are some strong advantages. Running models on your own machine gives you much better privacy. Sensitive data never has to leave your environment. It also gives you a lot more cost control. After the initial model download, you're not paying per request, which can be a major benefit at scale or during heavy experimentation. And once the models are cached, your system can continue to work offline, which is valuable in constrained or on-prem environments. The trade-off is that you're now responsible for how those models run. That's where the comparison with external APIs becomes important. External AI services are often very easy to get started with. You send an HTTP request, they handle the rest: scaling, infrastructure, and model updates. But this convenience comes with ongoing per-request costs and the requirement that your data leaves your environment and goes to a third party. With local Transformers.js models, you flip that balance. You gain full control over your data and your deployment environment, and after setup, inference is effectively free per call. In exchange, you have to think about hardware resources, model versions, and performance yourself. This lesson's architecture shows you how to take on that responsibility in a manageable, structured way. Stepping back, you now have a clear picture of what you're going to build. You're creating a Node.js and Express API that runs local AI models through Transformers.js pipelines without relying on external AI providers at runtime. It exposes three focused capabilities: a /support chatbot for conversational help, a /sentiment endpoint to gauge emotional tone in text, and a /classify endpoint to recognize what's in images. You've also seen the main reasons to favor local models: privacy and cost, along with the resource and maintenance trade-offs. In the next steps, you'll start wiring up these endpoints for real, connecting them to actual Transformers.js pipelines, and turning this architecture into a working local AI service.